Hi, everyone. My name is Jessica Hyde with Magnet Forensics, and thank you so much for giving me this opportunity to share my lightning talk here at the Open Source Digital Forensics Conference. I love OSDFCon and all of the great things it brings. I want to take a moment today to talk to you all about the Oxtera project. The Oxtera project is a project that was started by Jad Saliba here at Magnet Forensics, and the goal of this is just to bring digital forensics examiners who have the ability to share their time and their skill set to help with the pursuit of justice, serving those in need, from police agencies to public defenders to nonprofit organizations, charities, etc. What we do is we pair digital forensics examiners who are vetted against opportunities for them to give back in their local communities on a volunteer basis to organizations or those who really need them. If you want to get updates on the Oxtera project, you can just sign up here if you're interested in potentially having your organization supported. The website is theoxteraproject.com. If you're interested in volunteering, all you have to do is click this Get Involved link, and you can start the process to apply. The application is going to ask for a little bit of information about your certifications, your education, and your experience, as well as the types of cases you've worked, but as well as if there are organizations you can or cannot support, and the type of services you're opening to providing. Is it mentorship? Is it full forensics examinations? Is it other, and what other things you might be able to provide on a volunteer basis as a digital forensics expert and somebody who has these skills, which are oftentimes desperately needed to be able to help folks who otherwise wouldn't be able to get this type of analysis done. As part of the project, Magnet will also assist with software for those of you who maybe don't have access to software outside of your work environment and for volunteer projects. And volunteers, some of our initial sign-up volunteers include Trey Amick, Will Baggett, Alexis Brignoni, Ladrina Chern, myself, Jad Saliba, Lee Whitfield, and a bunch of others who are just really interested in giving back to the community. So we really hope you will join us in this effort. So if you're interested in looking for ways to give back, please check out theoxteraproject.com. Thank you so much for your time, and I hope you really enjoyed the conference. Bye all, see you soon.
Hi everyone, welcome to this small lightning talk on what I have called offensive forensics. On the latest Windows 10, this talk has everything to do with how does the most modern Windows 10 edition store and encrypt passwords that are used in applications, in the most recent applications, but more specifically the user passwords that might be stored or hashes that might be stored by users using picture passwords and PIN keys. So without further ado, let's stop this presentation like this and let's show you what we are dealing with. So this is the victim. I have just started it so you can see how it looks like. We have two users on this recent Windows 10. We have David, which has a PIN that just consists out of 4 different numbers, which of course we don't know. And then we have user Peter, and Peter has a picture password that we also have no idea how that works. So this is the premise to begin. And then let's move on to our forensics station, where I have already mounted at least the hard drive from Windows right here. So it should be boot or mounted on /mnt. And the thing I have created to be able to decrypt all this stuff is called DPAPA Lab NG Next Gen, which has different scripts that all work with a help function and so on, so it's able to decrypt blobs, credentials, Chrome, Edge, and so on, OpenVPN, separate Wi-Fi. All this is intended to be done offline in a forensic way, so on a backup or on a hard drive that like the one we can see right here. So let's try that out. So we have our scripts right here. So the one I wanted to show you that contains actually the details on the PIN PIN key and the picture password that we just saw is actually in the Windows vault. We can use this vault or the one that has been updated, which is this one. All these scripts has help functions. So for this help function, we actually need the system vault VCRD, so the vault credential files, which for system-wide are located right here. To decrypt these vault files, VCRD files, we need the system master keys, the DPAPI master keys, DPAPI master keys, which are actually located here for the system. And to decrypt these master keys, we need the system hive and the security hive. And this is optional, not important. So let's do that. Like this is how it looks like. I actually have to specify the specific vault. In this case, this would be 4B and so on. So with this given to our command, it will start to decrypt right now. So it will take on or look into this folder for the different files that are there, the credential files that are there, and has found two different files, right? This one and this one. The first one it has found is of the type next generation credential. This would actually be, for example, the PIN key. So if you provide the software hive as well, this would actually also show that this will be user David at least. So this is the SID for David. And then with this data in the next step, we can actually decrypt the PIN key, or given the PIN key, we can decrypt its original password. In the case of Peter, this would be the clear text Windows 10 password for Peter, which is apparently encrypted into this single file and encrypted with the system master key. So this is the picture password, and this would be the decoded clear text password for this user. So actually the more extensive script that I also have written would be this one. Let me show you, which also has a help, of course. It's a bit simpler. It only needs the Windows folder, and it will look for all the separate subfolders automatically based on that Windows folder. So we actually can provide that folder right now, which would be this one, right? We can also run this live, which is not the case. And then we should also provide it with the Windows Hello pin. But in case we have no idea which PIN key or PIN credential that is needed, we can ask it to perform a brute force on the pin, and then it will actually walk through all the different pin types like that. Notice that this goes pretty quick. We already have the pin right now, and it will now try to decrypt the user password, which is in that vault, by using that pin. So that's what happens here. So this is a very small demo on what is possible with this, and I'm looking forward to expanding this framework in the future. Thank you.
Hello, and welcome to my lightning talk about SFC, a secure and forensic file container format. My name is Florian Rudolph, and I'm a forensic and analytic IT expert at the Austrian Federal Ministry of Justice. I would like to start with some use cases for forensic container formats. The first use case is archiving. In law enforcement and judiciary, evidence and case data has to be stored, potentially for a long time, sometimes even over tens of years. Data safety is essential, especially encryption and data integrity. Also, we would like to minimize data storage usage. Another use case are regular backups. Here, data safety also is a key aspect. Additionally, for incremental backups, the system must be able to identify data, even if it is encrypted. The last use case I would like to cover are forensic containers and logical images. Forensic containers are used when seizing files, extracting subsets of other forensic images or containers, or saving data after being processed by a forensic tool. For these images, it is important to store the forensic information of data sources. Also, data integrity is a key requirement to obtain and/or maintain legal validity. Now I would like to introduce the secure and forensic container format, in short SFC. The format is a combination of a database, SQLite, and a container file. It would likely be tar. The key features of the container format include asymmetric and symmetric asymmetric encryption, file hashes for identification and verification, support for multiple occurrences of files, an extensible system for storing file and source metadata, and support for error detecting and correcting codes. In this slide, I'd like to give you a graphical overview of the format. Inside the tar container, the SQLite database with all meta information is stored. In this example, the two files file1 and file2 are encrypted with the key key-1, and the encrypted files are stored in the tar container. File 2 has two occurrences, being test1.mp3 as well as some folder /song.mp3. For data security reasons, all file metadata, like the source file path or MAC times, can also be encrypted with the public key key-1. The public part of the key is stored in the database. Using the hash of the encrypted file, the container can do self-verification of the stored data. The hash of the unencrypted file can be used for data identification, for example incremental backups or an SRL list filtering. This visualization is schematic, so in practice there will be more tables for handling files, occurrences, meta information, keys, and so on. Alright, let's sum up. To the best of my knowledge, there is no available forensic container format which meets all the requirements of the presented use cases, thus motivating the proposal of SFC. Last, I would like to present some design principles. First, I think it's very important for the file format to use and reuse existing specification and infrastructure. I therefore aim to design SFC to be interoperable with common open source tools. Encryption, verification, unpacking, and packing should be able using popular tools like OpenSSL, tar, and so on. Another key feature in the reference implementation is security and safety. For example, the usage of temporary unencrypted files should be minimized or, if possible, even omitted. The specification as well as the reference implementation, work in progress, disclaimer, very early stage, will be available on GitHub. So yeah, thanks for watching. Feedback and input is very welcome. And yeah, thanks for watching and bye.
The Polyswarm module for autopsy is meant for digital forensic analysts or security researchers who would like to determine if a given file has been infected with malware. To download the plugin, you need to go to github.com/polyswarm/autopsy module. There you will find the latest release and a README that goes through the installation, the setup, and the use of the plugin for future reference. Once you've downloaded and installed the plugin, you need to obtain an API key from Polyswarm. To do this, you need to go to the polyswarm.network. There you can set up a free account and generate a new API key. Once you have this API key, you're ready to set up the Polyswarm module and start scanning malicious files within Autopsy. Once you're ready to download the Polyswarm plugin, you'll need the .nbm file from the latest release. Once you've downloaded the file, you need to go back to Autopsy, go to Tools, Plugins, go to the Downloaded tab, click Add Plugins, direct to where you downloaded the Polyswarm plugin, click Open, click Install. Just follow the steps, restart Autopsy, and it should install. After you've successfully installed the Polyswarm plugin, you need to head over to polyswarm.network and sign up for a new free account if you haven't already. Once you confirm your account, you can go into your settings, the API key management page. There you can obtain your new API key. To finish setting up the plugin, now that you have your new Polyswarm API key, you need to go to Tools, Options, and there you will see the Polyswarm tab. You can paste your new API key here, click Apply, and OK. Now you're ready to start using the Polyswarm plugin. Once you've set up the Polyswarm module, you're able to scan any file you suspect of being malicious. You can look up the hash of a file as well as rescan a file. Doing these will bring back a set of results for each file with assertions from different engines in the Polyswarm marketplace. Other details provided are first seen and last scanned for that file, as well as the type of malware family and the SHA-256 hash for the file. You will also see a ranking of Polyscore. Polyscore is a single authoritative score based on a model of present engine detections weighted by past performance, indicating the probability a given file contains malware. To start using the module, navigate to a file you suspect is malicious. Right-click on this file and hit Scan on Polyswarm. You'll see a one-time pop-up that lets you know that you're sending this file to Polyswarm to be scanned. There'll be a progress bar on the bottom right. It takes a few seconds, but once it's done scanning, navigate to the left and click on Results, Polyswarm Results. Here will be all the files that get scanned. If you click on one, you can see the results easily. This process is the same with looking up the hash for a file as well as rescanning a file. After you reach the limits of your free community plan, a pop-up window will appear indicating so. You can then purchase an individual or enterprise plan that fits your consumption needs.
Hi everyone, I'm here and I'm glad to stay here with you in the online format to talk about introduce the forensics network with Wireshark. I am Eduardo Santos. I am a PhD candidate in computer engineer in UFRN in Brazil, a computer analysis, security plus certified OSDFCon chapter lead and JampaSec conference staff. And the motivation to talk about the subjects, everything goes through the network. Then we use the Wireshark to capture and decode data over the network, analyze network activity, perform pattern analysis. And Wireshark is an open source tool, and this is a pleasure to meet it. The Wireshark is this is the phrase. Okay, here is the summary part. Here is the detail, and below is the hexadecimal part of the Wireshark. Okay, and in investigation we needed a forensics methodology, and this one is an OSDFCon that obtains, strategize, collect, analyze, and report, because we needed to understand what is the problem and what do we need to investigate. Okay, another question is about where we install the Wireshark, the tool Wireshark, and you need to don't annoy the victim of the investigation, and a good option is to monitor the port in the switch. Another important to do and a great idea is to create our profiles to each type of investigation. We select the good profile. Okay, filters are important to create, and sometimes we get a lot of Wireshark trace or a large trace with mega gigabytes, and then we need to create filters to better understand the analyze and don't waste time. Here's an example of create IP address. Okay, about the attack and a victim, for example. Here we need to, when the capture was done, is the statistic capture file properties. We see when the capture was done, the time what the capture was done, the large file. Okay, static protocol hierarchy, we can see a lot of protocols, and in Wireshark we have the dissectors that needed to the Wireshark understand the protocols, that the communication between hosts. Okay, and then data, when we see data is because the dissector don't understand what is the protocol, for example, and we can create a filter, apply its filter, select it, and see these packets. In follow TCP stream, you can see is a characterize of the IRC protocol. Okay, and we decode with the right button of the mouse and decode as and select the RSC protocol, and you can see the correct dissector here. We can see below that the port, source port and destination ports are different from the IRC protocol for the full. Okay, another interesting thing to do with Wireshark is the decrypted traffic. You can see in the create a variable, variable. Okay, the name of SSL key log file here, and we need to put this profile and navigate in the network in the premise secrecy in Wireshark preference, and navigate usually normally on the browser. And here we can see the decrypted TOS. Here an example of the site. We can put credentials of fake a key, a fake password, create a filter in the IP address, put the, the master secret log name, and here you can see the page and analyze the key value and a fake password about and decrypt the TOS. Okay. Thank you so much. And the Wireshark is a powerful tool that we can do a lot of things about the forensic network. Bye.
Hello, I'm located from Tamil Nadu, India. Since I have been trained with autopsy digital forensic, so I'm think I'm eligible to answer the conference. Actually, what is autopsy? Autopsy is a premier open source forensic platform which is really fast, easy to use, and capable of analyzing all the types of mobile devices and device media, digital media. Its plugin architecture enabled sensibly from community developed or custom built model. Module. Autopsy evolved to meet the needs of hundreds of thousands of professionals in law enforcement, national security, litigation support, and cooperation investigation. So, in simple terms, what is autopsy? Autopsy is a computer software that makes it easier or simpler to deploy many of the open source program and plugins used in the Cloud Kit. The graphical user interface displays the result from the forensic search of the underlying volume, making it easier for the investigator to flag pertinent sections of data. The tool is largely maintained by basic technology cooperation with the assistance of programmer from the community. The company sells support service training for using the product. The tool is been designed with four basic principles in mind. What are the principles? It should be extensible, centralized, ease of use, and multiple users. It extensible means the user should be able to add a new functionality by creating a plugin that can analyze all or part of underlying data source. Centralized second point is the tool must offer a standard and consistent mechanism for assessing the features and modules. Each third point is ease of use. Autopsy browser must use the wizard or historical tool to make it easier for user to repeat their steps without excessive reconfiguration. Multiple user, the final point, tool should be usable by one investigator or a coordinator, coordinate the work of a team. Core browser can be extended by adding modules that help to stand a file called injection, and browse the result called view in or summarize result. Summarize result means called reporting. Collection of open source module that allows customization. Okay, let's just what is the Procket? Autopsy analyze the major file system like NTFS, FAT32. There are many file system by hacking all the file, unpacking support, standard RG, zip, jar files, tracking any zip values and putting keywords in an index. Some file types like standard email format or contact files are also part and cataloged. User can just do the index file for recent activity. Create a report in an HTML or PDF generating, summarizing important recent activity If time is short, a user may activate React feature that use rule to analyze the important files for Autopsy can save a partial image of this file in the BSD format. As of now, we have version 4 which is runs on Windows, Linux and Mac operating system. Okay, thank you.